In the next problem in the version 1 set, we have two cubes, one with a volume of 85 and one with a volume of 8. And we want to calculate the factor by which we multiply a side of this cube to get a side of this cube. So that what we're going to want is some kind of proportionality that gives us the side if we know the volume. Now we know that the volume is kx cubed. So it's going to turn out that x is going to equal some kind of a fancy k. That's a real bad looking fancy k there. But let's pretend that that's a fancy k times the 1/3 power of the volume. We get that easily if we solve this for x. Actually then we're going to multiply both sides by the reciprocal of k and then take the 1/3 power of both sides, because the 1/3 power of x to the third, of course, is just x. And we're going to get x equals some k times v to the 1/3. And this k will be the reciprocal of this k raised to the 1/3 power if you're interested, but that's not important. The important thing is, if volume is proportional to the cube of x, then x is proportional to the cube root of the volume. Now once we know that x is proportional to the cube root of the volume, we can simply write x2 over x1. Well, we could go through the whole process. We could write x2 equals fancy k times v2 to the 1/3 and x1 equals fancy k times v1 to the 1/3, and then divide those. We see that the k's would divide out and we would end up with v2 to the 1/3 over v1 to the 1/3, which is just v2 over v1 to the 1/3. In other words, we get this by the same process that we used on the previous problems. In this case, since the volume of the second cube is 8 and the volume of the first is 85, then the ratio of x values, the ratio of side lengths, will just be 8 over 85 raised to the 1/3 power, which comes out to be approximately 0.46. So if a cube has 0.46, one cube has 0.46 the side of another, that is, if x2 is 0.46 of x1, then if the volume of the first cube is 85, the volume of the second will be 8.